Hello, this is I hope an improved recording of our class discussion. This is us creating a music player, and I called it MPX as an experimental. It's sort of a homework assignment lab. It's not in your textbook, it's a bit more involved, but I think has a lot of content in it. So here we start off as our programmer. Funny movie, Young Frankenstein. Well, at least I thought it was. Anyway, here's our initial program. It's hard-coded, which is a very good vocabulary word for you, hard-coded. In other words, this program, once it's compiled and distributed, it only plays one song. And it's kind of a monster piece of code. All right. So your homework assignment is it's simple, but I want you to understand this code and other things. And I want you to convert it so it reads a note. What's a note? Well, we'll find out these things here. Well, this is a note, and this is the length of time. Two numbers, note, or frequency, and time. To study it, think about it, and putting this in a file, a text file. Well, you'll put the frequency number down first, a blank space. Remember, that's our symbol for a blank space. And another number, the duration. And both are integers. And at the top of the file, we'll have the length of, length of what? Length of the file. It'll tell us how many pairs we have, pairs of numbers. And we'll have a nice extension for our file. We'll call it MPX, for Music Player Experimental. And your new version of the code will ask the user, hey, give me the name of a file. And we'll have a file like this that we will write. We'll put MPX at the end, and we'll give it a name, and we'll play Mary Had a Little Lamb. There are many others on the internet. Remarks. The beep function is old, very, very old. It's when we called machines PCs. And it was based on this chip. We don't have to know any of the electronics for it. D means data. Notice there are 8 data bits in here. And there are power lines. This is plus power, and this is ground. And the other stuff you can learn about in an engineering class. And this is the address line, which gives you combinations 0, 0, 0, 1, 1, 0, and 1, 1. And looking at it, it tells me there are 4 things I can control in here. I don't know what they are, but there are 4 things. But we're not a systems programming class. We don't have to go into it. Somebody did this work for us. And what did they do? They built this function inside the C++ library. Don't worry about this thing. It stands for double word. As far as we're concerned, we can just use integers. And bool, well, that's just bool, which is an integer here. You see the frequency, the sound, frequency in hertz. You probably have had that in your math classes. Right? Frequency is equal to 1 over the time period. And they call these frequencies measured in hertz. That's the units. You got to give it a name. The smallest number you can have is 37. What does that mean, the smallest number? That means a speaker can have a very low sound coming out, or up to 32,767 hertz. And these are the numbers in hexadecimal code. The sound is measured in milliseconds. So 1 second is really 1,000 milliseconds. So if I want to hear a sound last 1 second, the second number would be 1,000. And you can experiment writing simple programs. This only works for Windows. There might be something in Mac called NSBeep, but I'm not sure. So one of the things you have to do is to convert your file so it reads a note. And the note will have a duration, and I didn't write it there. Here I wrote a frequency and a duration. A length of the file and an extension. So what I'm trying to do now is pull out this idea that I have number, 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 all the way down to 2 numbers. And I count how many pairs, and I put that number at the top, the length of the file. Drawing things, I think, is very, very helpful, or whiteboarding. So here we have our program. Here's our hard-coded commands. What I want to do is get rid of this whole thing of beeps. I would just cut and paste it into a file and delete all these extra things. You could do a find and replace, or manually delete everything, or retype it. Somehow you have to get that in there and then add this number 25. Again, how did I get 25? I counted 25 lines. Next, I was using Visual Studio, and I called it Music Player 1, my project. Actually, I think I called it Hello World 1. But I clicked on this thing, and I said I wanted to add a new file. And I created this file and saved it. Sometimes you get like a .txt here. If that happens, what you simply do is you try to rename this thing and get rid of that one. Rename it. So you don't need this, not needed. Here we have all our libraries, and here's a string to open up files. Here's our window beep, our standard C in and C out. And this thing here, because I'm going to do something archaic, I'm going to ask the system to create an array on the fly, a dynamic array, because I don't know how big Mary Had a Little Lamb is or other files coming in. Maybe I have the entire Wagner Rings trilogy coming in here. Who knows how big that is? So what I'm going to do is have a new command, new, where I can ask the system to create an array for me on the fly. So now I'm partitioning my problem into parts. One part, open the file. Here it's a demo. I'm not going to type it in while I'm testing the program, so I'm going to just initialize it manually. 2, I'm going to see if I opened up the file. And if I didn't, I will crash and burn. Next, I haven't figured this out yet. I'm going to get all the data in, close the file, and end it. I somehow want my main program to do these 4 steps. And again, here is the extension I made up, .mpx. Use it for branding later. Input, file, stream. This just means F. I use the letter F to mean file, and in for input. I made that up. If the file were going out, I would have called it F out. If you have a bunch of them, I could give them more exotic names or more appropriate names. Next, this thing here, I come down to this part, I ask, did it open up? And notice I say not. That symbol means not. So when I read this, I say if file N is not open, report the name of the file and that it wasn't found, so that we don't go crazy seeing a blank screen, and then I crash the program right here. I say program is done. Better crash and burn early. And then of course, if everything's successful, I close up the file, clean everything up, close my file, because I don't need the file anymore. Theoretically, I got my data. So where am I up to? This part. I know how to open up the file and see if it's open. I know how to close the file up. Now get the data. Great. I'm partitioning my problem into parts. Now, here's my file. This is the file that we created a little while ago. The first thing I want to read in is the number. In this case, it's the number 25. But again, we don't know what that number is. That number could be any number. Next, I want to read 2 of these at a time. So what I'll do is I'll say file, whatever number you see, put it in the array, frequency I, file, the next thing you see, put it in duration I. So I have these pairs. Oh my goodness, look at this monster. This is that one step. The one step says, all right, first, let me go back. Duration. Duration is a pointer to an integer. Well, actually, I really mean an array. So this is a shorthand notation for saying it's an array, but I don't know how big it is. Frequency is a pointer to an integer. It's really an array, and I should put comments here that people know I'm talking about arrays. Next, the file's already been opened way at the top of the program. I get here, and I grab the first number. In our case, it would be the number 25. Then I come here, and I ask the system to create an array for me. How big? Big enough to fit 25 items. And I get two arrays, each of 25, one that holds 25 different frequencies and the other one 25 different durations. And I use them together like peanut butter and jelly. Now, this says new. Now that's where it's asking for the data. No throw means if something goes wrong, don't crash the program. If something goes wrong, it will set duration or frequency to the word null pointer, which is the number 0. Null pointer. It's really the number 0. So I look, is the frequency equal to null pointer? If yes, something went horribly wrong. Or is the duration equal to null pointer? Then something went horribly wrong. So I will report back. If one of these went bad, I will just say allocation error and then crash and burn right here. Next, this all worked out. I got a file, I got memory. So now I'm going to fill both arrays with data. How many data items? 25. 25 data items. Where did I get that? Right here. Whoops. I got that from, if I get my pen back, excuse me. Where did I get that N? Right here. It's the same N that I'm using. All right, now this is a lot to look at and one giant chunk. So what I'm going to do, after I look at this, we're going to move on and look at them more closely. It's not much more to see or say. Go to the file, get the first number, put it here, get the second number, put it there. And it repeats n times, getting each pair, frequency, duration, back, next frequency, duration. It loops around, frequency, duration, and again. How many times? In our case, 25, but it depends on the file. Next, I want to see if I did it right. So I'm just going to look at all 25 pieces of data. I just want to look at them. Next, I asked the system to create data for me. I'm done with the array, so I'm going to ask C++. Here, I'm going to give you back my duration and my frequency. Take it all back. So again, this is, it's not quite production quality, but we just don't want code to crash. What happened? I don't know. Was it my computer? What went on? So we look at these two values that are returned, and if either one of them is null, I report that there's a problem and I leave. That's all that's happening there. And when I think of it, I think of this as one chunk of something happening for me. So in my mind, this is like a function that goes in and it either crashes or it goes on to the next step. My next step, even though these should be separate, I looked at them together and I have a comment here, fill both arrays, go into the file. How many times? Again, it's that number that we found from the top of the program, 25, whatever that number is. So this will loop 25 times, filling the frequency and duration. And instead of saying beep, I said, let's just print it out and look at it. Now, if you have a Mac, this is all you can do because beep won't work for the Mac. So you can see the numbers change. And then when we're all done we give it back to the system. This is an old technique. It's manual memory cleanup. There's a better system. Managed memory means let the C++ runtime environment handle it for you. That a C++ can add extra code to clean stuff up. Nothing is free, of course. No free lunch. It's not very expensive to do. When I say expensive, I simply mean in overhead. It takes a little bit more code. Your program's a little larger. Here, it's faster and customized. You're in charge of everything. But if you make a mistake, it's called a leak. Actually, technically, it's called a memory leak. And that really can be a nightmare to find on your own, and there's actually software products to help you find leaks. All right, so here's our new piece of code. Our code is a monster that's not very happy. Look at this thing. Oh my goodness. We just went through this entire chunk of code and not happy. We have a monster of code. What is going on here? I mean, we can kind of figure it out. It's not difficult. But the idea is we want to start, good habits early, not to avoid Frankenstein monsters. So we get a brilliant idea to use a structure. That's us with a brilliant idea. Let's glue these two variables together. I'll call it frequency, duration. I put some comments here. Actually, these comments are silly because it's only for us as we learn. But in the real world, you would say something a little more descriptive. What is going on here? And for us, I say, now we can say note A. So note A has two components, frequency and duration. You get two variables in one. That's great. I don't have to cloud everything up. I can say note A. So our Frankenstein monster is getting a little nicer. Why? Well, we go in, we find out how many notes we need, but instead of creating two arrays, I create one array of notes, and I call it a pointer, not to integers, but a pointer to notes. And now I was a little cheap here with my code. I should print a message out, but I didn't want to clutter everything. If we don't get any memory, just crash. It's not going to happen. We're going to get memory, but in the real world, you just can't even do that. Now here, we're going to fill both arrays again. Same concept. We go into the file, except now, the first piece of information, when we say go to MPX, our array, this is an array right here. There's two parts. So I go to MPXI, get the frequency part, so put one number in here. MPXI, get the next number in the duration part. Remember, MPX is full of notes. So when you say MPXI, you're actually saying, I have a note here. And a note has two parts to it. Same thing with printing out the data again, just looking at it. And deleting it works the same. So we're a bit happier now. Our monster's a little more pleasant. Still a monster. So we do need some more. We need to clean up our monster act. That's sort of, we don't want to have, we want to have a nicely dressed program. That's us, programmer. So maybe I could take some of this stuff and bury it deep inside something weird. Like, what? This says, tell me where you want the output to go, tell me the name of the data, and how much data you have. Because we're using arrays. Vectors would be far better than this. So where do you want it to go, and what are you sending there? And this could even send it to a file, technically, not just a screen. So how do I do that? I'd like to see something like this. Send all notes. Where? Send it to the output screen. Or later on, we could send it to file out. Send what there? All this stuff. Great. So what is cout? Cout is really an output stream. And this means reference. So C out. This out will be a live reference to an output stream. Yes, the real output stream. Next, here's our array. This is perfectly fine. You could put a star here too, it works as well. There's a bunch of notes. This is how many notes we have in there. And you take a look. The first thing we do is we take n, and if we're sending this to the screen, I tell you there's 25 notes. I'm actually just printing out the whole file and sending out this to the screen. Why the screen? Because I'm using cout. That's the console. This could also go to a file. It's a very versatile function. So now our program's looking a little cleaner. Not much. I'm still not thrilled with it. Neither is our program. So we do love our code, so we want to make sure we get it the very best in coding. So I'd like to make main even smaller. And here it is. I'm going to say, give me the name of a file. Just give me that file name and tell me where you want to put it, and I'll fill it up with data for you. And then you can take a look at it. Now read how this goes. Name of the file, get the music, and this is not a great name, but it says stream all notes. Ah, like streaming video, streaming music. Oh, cool. So here we are, as good programmers, lovingly taking care of our code, making it better and better, experimenting. Here's our project manager, finally showing his face around because they're getting impressed with our code. You give me the name of a file, I'll open up the file, check to see that it was opened. Once I find out it's open, I get the data I get the size of the file, and then I turn around and say, oh, let's see something here. Did I make a mistake? No. Then I create a pointer. I ask the system, go get me a big chunk of memory to put all this data and tell me where I put the data. MPX will know where the data is hiding. Next, if something goes wrong, we just crash. Whoops. And then we go to the file and get the data and fill up MPX. And I tell you where MPX is living. MPX is somewhere, I don't know where, in memory. And it's really big. And I also return back n, so you know where the song is and you know how large the song is. Of course, we need more. So, I'd like to provide menus. Yes, we're getting much more sophisticated. And we want it to be menu driven. So our next version of this code will be that you'll be able to load different files in, change them, save them with different names even, using this idea of a command interpreter or menu driven design. The idea is we will show the user, we'll give the user choices. What would you like to do? And they select a choice. And we have a simple loop. They see a choice, we do whatever they want,